Today I'm going to talk about the flash translation layer and wear leveling. I'd mentioned in a prior lecture that solid-state drives and other flash-based memory rely on firmware that's loaded onto chips in order to store data and make it available for reading at a later date. There are a number of algorithms or programs that are part of the firmware which carry out the functions of file management within flash memory. Before I go over the two aforementioned algorithms, I'm going to review some of the basic differences between how hard drives and flash memory store data. The most recent hard disks store data in sectors and clusters. The way that these sectors and clusters are mapped on the hard disk is through logical block addressing. A hard disk is broken into individual logical blocks. Each and every block on the disk has a unique address. When a stored file is referenced, it is referred to by the particular blocks that it occupies. The file will stay at this location unless the disk is defragmented, thus reshuffling the location of the individual blocks where the file is stored. If you want the physical addresses of where a file is stored, you can refer to its master file table record, which has all of the cluster run locations in memory. Flash memory stores data in pages and blocks. However, it tries to emulate what hard disks do by using the same geometry scheme. Thumb drives and solid-state drives are still formatted with file systems such as FAT32 and NTFS. So when they're forensically imaged, you will see their geometry displayed in sectors and clusters. When it comes to storing and retrieving data, hard disks are predictable and reliable in their storage. There are two algorithms that are part of the flash memory firmware that affect the storage and retrieval of data. These are wear leveling and flash translation. First of all, there is currently no standardization in the design of solid-state and flash memory. There are a number of manufacturers, each with their own proprietary firmware design. Besides being proprietary, the firmware is also inaccessible. The code on the controller chip would need to be reverse engineered to be accessed. The firmware is also considered trade secret. Every manufacturer has their own secret recipe and they don't want you to know what it is. The first of these two firmware algorithms that I'm going to discuss is wear leveling. Unlike a hard disk drive, which is a stack of electromagnetic aluminum disks, flash memory is composed of blocks of floating gate transistors. The blocks are full of individual cells which can hold an electronic charge. The presence or absence of the electric charge translates to a binary 1 or a 0. There are only so many times that these individual cells can hold an electric charge before they burn up and can no longer function. When this happens over a period of time, portions of the memory blocks will become unusable. As a method of countering this, or attempting to prolong the inevitable complete burnout, engineers developed an idea known as wear leveling. Instead of writing to the same individual cells electronically over and over again, an algorithm writes to different cells every time a file system writes to memory. This way, the individual cells get used in a more uniform fashion. How exactly this is accomplished, however, depends on how a manufacturer wrote the firmware to accomplish this task. The inherent problem with using this solution is that over time, files will be written to multiple different physical locations. Unlike a hard disk, their location will not be predictable. Sometimes evidence of wear leveling can be seen at the hexadecimal level, where data that was written to in one sector did not get completely wiped when it was moved to another block. The second algorithm that I'm going to discuss is called flash translation, or the flash translation layer. As I mentioned previously, flash memory attempts to emulate how a hard disk works. When we save and retrieve data, or when we try to recover it when data gets deleted, we use sectors and clusters just as we would on a hard disk. In order to alleviate the problem of the shifting location of data in memory, developers came up with a concept called flash translation. Flash translation is a virtual mapping from a sector cluster logical location to a physical location on a flash memory block that changes with time. For example, if you have a 200 megabyte MP4 video on a flash drive that's formatted with NTFS, the file system may say that the video file begins at cluster number 223465. If you come back multiple times, the file system might give you the very same cluster number for the starting location. Where that video resides physically on the blocks and pages of flash memory will very likely be different each time you access the storage device. Again, how frequently such a mapping takes place and how it is accomplished depends on the design of the manufacturer firmware. So, what significance do these algorithms have with respect to digital forensics? With this question, I also reiterate the fact that the firmware which contains these programs is proprietary and inaccessible to end users. Specifically, this means that there are many, many different versions of flash memory firmware, each with differing standards on how frequently data gets remapped physically on the media. The significance that this has forensically relates to how deleted data is recovered. Wear leveling and flash translation can greatly reduce the amount of time it takes for a deleted file to show signs of decay after overwriting. It can also cause the integrity of certain files, such as video files, to become corrupt and not function correctly after recovery. What this means overall is that forensic recovery of data when it comes to flash memory becomes very unpredictable.